Hi, welcome to statistics class, and this is our lesson 1, regression analysis. What is this regression analysis? So regression analysis is a conceptually simple method for investigating functional relationship among variables, which I know you understood in your elementary statistics what is variable. So what is this regression analysis? It is also a statistical technique used to study the functional relationship between two or more variables. So this regression analysis also established a causal or a possible causal relationships between dependent and independent variables. And this also predict the value of the dependent variable given the value or the values of the independent variables, or we can commonly call these independent variables as x variables, as we can always see in functional equations or in some equations. So, and also this regression analysis, it explains the variation of the dependent variable that can be attributed to the independent variables. And also remember that in regression, the independent variables or the x variables and dependent variables or the y variable are clearly defined. And so let's have some example. We have the life expectancy as predicted by income, the education or the length of schooling in years, and then your health status or others. So what is this life expectancy? It is actually the estimate a person of a given age that can expect to live. Let's say our life expectancy is 72 years old or 75 years old. So is my life can be predicted by my income, by my education, by my health. Let's say if I am poor, I can live long. If I am rich, I can live long because I can afford some nutritious food or some medicines. Or if I am poor, will I live shorter? So there's a lot of factors that can be attributed to our life expectancy or also your education. For example, uh, the more we study, the more stressed we are. And so it lessens our or it decreases our life expectancy. So we have to figure it out. And then our health status, of course, if we are unhealthy, then we're likely to live shorter. So regression analysis could help us figure out our life expectancy given the variables, given the factors mentioned. And also we can have an example of cigarette consumption. So what is this? It is related to the various socioeconomic and demographic variables such as age, education, income, and price of cigarettes. So when we say age, if I am still teenager, of course, I will not or I will have a lesser cigarette consumption. But I'm not telling you to consume cigarette. Better not to. And then if I have higher income, so we can have this study or we can use regression analysis in some of this study. And so let's go on. So we have mentioned some examples in our previous slide. The life expectancy as predicted by income or education. Now, we convert this one into a functional relationship or to our equation. So the relationship is expressed in the form of an equation or a model connecting the response or dependent variable and one or more explanatory or predictor variable. So in a given the functional relationship or the equation, we have the y hat is equal to beta naught plus beta 1 x. So if you can see here, we only have one predictor or one variable or explanatory variable or one x variable. So in our example previously discussed about life expectancy, we can have the predicted value of our life expectancy is equal to from a certain with given our data, we can compute for our intercept and then for the slope, and then the predictor is our factors such as income, education, uh, and health and some other factors. But let's just say if we only have one explanatory variables, then example, we can have the health factor. So this is the functional relationship or an equation. So let's study this one further. So we denote the response variable by y. Okay, the response variable by y in the set of predictor variables by x, where p denotes the number of predictor variables. So the true relationship between y and our x factors, our explanatory variables such as x1, x2 until xp, can be approximated by the regression model. So what's this regression model? It is y is equal to the function of x1, x2 until xp plus epsilon. So what is this epsilon? This is, or epsilon is what we call the random error. So where epsilon is assumed to be a random error representing the discrepancy in the approximation, or we can call this random error as error term, okay, in our regression equation. So again, the error term or is the difference between the expected value and the actual value. So what is this expected value? This is our mean and the real value that we have. So any difference from that is what we call the error term. And this has to be very small. And so we have to make it small. And this error, random error, it accounts for the failure of the model to fit the data exactly. So the function x1, x2 to xp describes the relationships between y and our factors. So this is an example, and this is the example in the linear regression model. As you can see on the screen, we have the y is equal to beta naught plus beta 1 plus times x1 plus beta 2 times x2 until beta p xp plus our error term or the random error. So the betas is the regression parameters or coefficients. And this beta here are unknown constants to be determined from the data. So the predictor or explanatory variables are also called by other names such as independent variables, covariates, regressors, factors, and carriers. However, the name independent variables, though commonly used, is least preferred because in practice, the predictor variables or our x variables are rarely independent of each other because even the x variables itself are correlated with each other. So some are just call it as the predictor variables. And so, if we have this regression analysis, where can we apply this regression analysis? Actually, regression analysis has numerous areas of applications. And these are the partialists. In economics, we could apply regression. In finance, in business, in law, in engineering, in physics, in education, in sports, in history, sociology, psychology, meteorology, medicine, biology, chemistry, and some others. And regression analysis is one of the most widely used statistical tools because it provides simple methods for establishing a functional relationship among variables, and it really has an extensive applications in many subject areas. So let's learn or let's have some example in some sciences. Let's say in agricultural sciences. So the Dairy Herd Improvement Cooperative in upstate New York collects and analyzes data on milk production. So we can see here in the table 1.1, we have the variables for the milk production data. So we have our Y variable or our dependent, the current milk production. So what is the volume of our milk production given the data we have previously, given the fat or percentage of fat in milk, percentage of protein in milk, the number of days since present lactation, and the number of lactations. And we have also have indicator variables. So in this example, one question of interest here is how to develop a suitable model to predict current milk production from a set of measured variables. So as we can see in the screen with the following variables. So here's one of the example how we can apply regression analysis in agricultural sciences. Also, we can have in even in rice field, not only in this animal sciences field, also in crop sciences. We could also use regression analysis in prediction of our rice yield given the amount or the volume of insecticide and the amount of fertilizer. So there's really a lot of application of regression analysis to different disciplines, to different sciences, especially in agriculture and in agricultural sciences. Next we have in history. So, a question of historical interest is how to estimate the age of historical objects based on some age-related characteristics of the objects. So, we have these variables, our y. So, what is the estimated year of skull formation? And then we have them with the variables that we have the independent variables or the explanatory variables we have based on maximum breadth of skull, pragmatic height of skull, the length of skull, and nasal height of skull. So if the skull has a size like this, then what is the approximation or what is our response variable, which is the year of a skull. So we could also apply the regression analysis in history. And also, we could use the regression analysis even in our government and governance and political sciences. So, information about domestic immigration or the movement of the people from one state or area of a country to another is important to state and local government. And there are a lot of factors that influence domestic immigration. We have the weather conditions, the crime, the tax, and unemployment rates. For example, if there's a lot or 1,001 million immigrants, then what is the reason or the predictor? Can we say because of unemployment? Of course, it can be accounted to our immigrations. So here's also one area where you can apply the regression analysis. Also, we could apply regression analysis in predicting the number of tourists in a certain tourist site. So we could use regression analysis as well, given that we have lots of predictor variables. And also, we could apply regression analysis in environmental sciences. So, in a 1976 study exploring the relationship between water quality and land use. So, given the variables that we have on the screen in table 1.8, our response variable or our y is the mean nitrogen concentration. You know, a question of interest here is how the land use around a river basin contributes to the water pollution. So as measured by mean nitrogen concentrations. And then we have the predictors or the X variables, the agriculture, percentage of land area currently in agricultural use. And then the forest, if there's a lesser percentage of forest land, does it affect our rivers? And then the residential, the percentage of land area in residential use, and then commercial industrial, percentage of land area in either commercial or industrial use. So these variables, these X variables, the predictors or explanatory variables, does it have an effect or a functional relationship or effects with our nitrogen concentrations on our rivers. So in this area, in this study, we could also use regression analysis. And so those are just one of the few of the areas where we could use the regression analysis. Actually, there's still a lot. We could also use regression analysis in medical sciences, in health sciences, and in education, and there's a lot more. So there's just an introduction, and thank you for learning, and may God bless us. So see you in our next lesson.